Let's say you're working for NASA or SpaceX and you're part of a group that's trying to get a crew up into space, maybe to the moon or over to Mars. One thing that you need to get settled that you'd be very interested in is, what path do I want to send this crew on? Another question that you should ask and that you would be very curious about is, what kind of space debris do we need to avoid on our way out and on our way back in? And then also, as you come back into the Earth's atmosphere, what angle do you want to hit the atmosphere at? How fast do you want to be going? Maybe you even want to care about the acceleration and the jerk. So if you're analyzing all of these things, you want to be able to describe these paths of the spaceship and the debris very precisely. One way you can do that is with parametric curves, where you just let each component x, y, and z be described by some function of some parameter. Usually we use t. As you're analyzing the objects that are moving along these paths, it can be much more convenient to describe these in terms of vectors, the paths in terms of vectors. So you can just take each component x, y, and z, let those be the components of a vector, and then you've got a vector valued function where you plug in some t, you get out a vector whose tip is at the point x equals whatever, y equals whatever, z equals whatever. Once you have the paths written down as vectors like this, you can find much more elegant ways of describing what's happening in space.